So it's given here that we have a triangle whose angle measures are in arithmetic progression. It's also given here that the ratio of the smallest angle, which is in degrees, to that of the greatest angle, and that's given in radius, is 60:pi. So we have to find out the angles of the triangles in degrees. Let us begin. So since the three angles are in arithmetic progression, so let's say let the three angles be that the three angles of the triangle be given by, so we'll take the first angle or the smallest angle as a minus d degrees, followed by a degree, and then we have a plus d degrees. So we're choosing the numbers in such a way that these three numbers must be in AP or arithmetic progression. Clearly we see that the three terms are in arithmetic progression because they have a common difference. Okay, fine. Now we know that when the sum of the three angles of a triangle, they sum up to how much? 180 degrees. So we have a minus d added to a plus d. Since all of them are in degrees, so they sum up to 180 degrees. So we have d and negative d cancelling out. That leaves us with 3a. So 3a is 180 degrees. So a must be equals to 60 degrees. So let's keep it aside. We're going to call it number 1. Now it's given here that the ratio of the least angle, which is going to be a minus d, to that of the, this is in degrees, to that of the angle, the greatest angle, which is a plus d. So this is in degrees. So both of them are in degrees. So it is given here that this ratio is 60/pi. However, this is not exactly true because it's given here that this must be in degrees and the greatest angle, which is the denominator, but this has to be in radian. Only then the ratio is going to be equivalent to 60/pi. So that means our goal will be to convert a plus d to from degree to radian. Okay, fine. That's, we know that 180 degree. So that's equivalent to pi radians. We know this. Now 1 degree, so that must be equivalent to pi over 180 radians. Now since we need a plus d degree, so a plus d degree will be simply a plus d. All we have to do is multiply it with pi over 180. That means this will be multiplied with pi over 180 such that this entire angle in the denominator will be now converted to radian. So we have a ratio of degree to that of the radian measure. So that's 60/pi. So let's solve for the value of d. So that's very simple. So we have a value we have obtained, that's 60. So we have 60 minus d divided by the denominator. We have 60 plus d multiplied to pi over 180. So we're going to take 180 to the numerator. So we have 180 in the numerator. This will be equals to 60/pi. Now clearly we can factor out pi from both sides, and 60 times 3. So that's 180. So we have now, we have 60 times 3. So that's 180 minus 3 times d. So that's 3d equals to, so we're going to cross multiply 60 plus d with 1. So we have 60 plus d. This gives us 4d equals to 180 minus 60, so that's 120. So our d value comes out to be 30 degrees. Fine. Now we have our d value as well as a value. Well, we can substitute this here. The a, which is 60 minus d, so that will correspond to 30 degree. A we have already obtained, so that's 60 degree, and the greatest angle a plus d, so that 60 plus 30 will be 90 degree. And we see here that option number E, so that's going to be the correct option.